Professor Wergely's here. We just got a basic thread up and running. Let's take a look at a more complicated thread. We're going to look at counter thread number 2. You'll see here, I still have a count2 variable, and we're going to implement and still print it out to the console. But I also want to now output to a text area. So first step, how do I create a thread? The first say that we learned is to extend the thread superclass. This is the basic and most easiest way to get a thread up and running. The reason this is easier is because the thread already has the run method, and I have access to the start method directly from the thread superclass. We'll talk about what that means when we get to counter runnable. You'll notice when I do extends thread here, I have a warning. It's saying, hey, I see this run method in the superclass and in the subclass. Are you trying to override the method? I'll click on the warning and say yes. We'll add the override annotation. Now, even if I don't add this override annotation, the run method will be overridden. The only difference is this is easier to read, and it confirms to the compiler, yes, this is what I'm trying to do. Even if I don't put this here, I'll still override the method. It's just this is the proper programming practices, the proper way to implement and override a method from the superclass. Now notice this for loop. I have for loop. Instead of I use K, doesn't really matter. I'm going to count2. Count2 will be passed in as a parameter to the constructor and save as a class field. I also have a text area. Text area will be passed in from the constructor. And then I want to output the information or the message not only to the console, which is system.out.print, but also to the text area. You'll see I have my homemade, which is the proper way to stop a thread in the middle of execution. So I have my if stop is true, go ahead and return. You'll see the default is false. This is a public variable. If I wanted to use proper programming techniques, I'd create a method here and have this as private, create a stop method that sets the stop variable to false. But this is ThreadPlayground. So we're just taking a look at different threads. We're going to focus mainly on threads instead of proper data encapsulation. But if you implemented this for your final project or a challenge, you would want to implement proper data encapsulation. So now I have extends thread. This is now a thread. Counter thread 2 is now a thread. If I get rid of this, so if I do not extend the thread superclass, even though I have the run method here, this doesn't mean that it's a thread. Okay, I have to either extend the thread superclass or implements the runnable interface. That's back on the slides. This is going to be on the final exam. So you'll want to know the 2 ways to create a thread. Okay, define and start threads. There's 2 ways. Provide a runnable object or subclass thread. Okay, this is the easiest way. This is the easiest way. But the bad thing about this is now I'm wasting my inheritance. Let's say I made my own custom class. Let's say I wanted to thread 2 extends from counter thread 1. Well, now I couldn't do that because I'm using the inheritance. Java does not have multiple inheritance. So I can't say, okay, extend thread and also extend counter thread. Okay, I can't do that. I can't do that. I can only do one. So the bad thing is if I use extends thread, I'm wasting, so to speak, my inheritance. Now, if you weren't going to inherit anything anyway, this is the quick and easy way to get a thread up and running. But following the textbook, it's not the best way. The best way would be to implement the runnable interface, which we're going to talk about next. First, let's talk about how we would output to this text area. Now, what I could do is I could just do it directly. I can say, oh, okay, I'm going to say text area, and I'm going to call this set text, just like we've done before. I'm going to output the message. And when I output the message, you'll see I print ln, which is on a new line. If I just did print like this, it would print the message on the same line. So I have an ln here. So every time I have a new message, it's going to be on a new line. It's not going to do that with the set text. So I have to manually define it to be on a new line, which this is how you do it in Linux. On Windows, it may be RN or RC. I can't remember. I do think -N will work on Windows and NetBeans though. So I'm going to print the message, put it on a new line. Now the problem here is I'm updating the UI. Okay, I'm updating the UI. So if I run this, if I just have a basic application, so let's say I start the first one up, now I start the second one up, we actually need to implement this start button. It's probably going to run. Okay, it's probably going to run. You're probably not going to have any issues, but it's not following proper programming techniques. So one thing you want to know is, how do I create a thread? There's two ways: extend the thread superclass, implement the runnable interface. How do I stop a thread? You need to let the run method return. The other thing you need to know is, if a thread updates the UI, the user interface, that update needs to be executed on the main thread. Okay, so when a thread updates the UI, that update needs to be executed on the main thread. Remember what the main thread is. The main thread creates additional worker threads and also executes the main method of the program, which also updates UI elements. So how do I do that? I call platform and I call the run later method. Now, we did this in click point animation, but you may not have been aware of what exactly it means. So if I want something to run on the main thread, I call platform run later, and I actually put this inside. Now I could have everything here. I could have the for loop, and I could put everything in platform run later. But that's going to defeat the purpose of concurrent programs. For example, let's say I have 4 threads, and all of the threads execution, I put it on the main thread. Well, then there's no point of having additional threads. So what's going to happen here is the message is going to be calculated on the worker thread, and then only the update to the UI is going to be executed on the main thread. And what's this going to ensure is, if I have 2 threads updating the UI at the same time, I would get a runtime error. But by putting it on the main thread, it'll ensure that it's put into a queue and 2 threads will not update the UI at the same time. You also have a problem with this when looking at files. You'll probably learn more about this in operating systems. If 2 threads update a file at the same time, the file will become corrupt and you're not going to have all the information there. So what you'll do is you'll lock the file, have 1 thread update, then you'll unlock the file and have the next thread update. Okay, and that's what we're doing here. Whenever we're updating the UI, we put it in this run later. What is this run later? If you ever wonder what a method is, right click and do a show Java doc. Run later is like a queue-like system. Okay, so it's going to put it in the queue and it's going to run it as soon as it gets a chance. Okay, they used to have another way to implement on the main thread, but this is the current way to implement elements on the main thread. You'll see run the specific or specified runnable on the JavaFX application thread. So when they call the application thread here, that's the same thing as me saying the main thread. The application is the main thread. You'll see this is for JavaFX. Okay, and it'll run it at some unspecified time in the future. Normally, it runs it immediately. So as soon as you call it, it'll run it immediately. But if the main thread is busy doing something else, it'll finish that first and then run your update to the UI. So imagine I have 4 threads. They all call this run later at the exact same time. It'll put thread 1 in the queue, thread 2 in the queue, thread 3 in the queue, thread 4 in the queue. It'll execute thread 1, then it'll execute thread 2, thread 3, thread 4, and then all 4 updates will be done to the UI, but they won't be done at the same time. It'll be done one at a time, so we don't create some runtime error. Now, we want to see this work. We actually need to go to the controller and we'll do handle start to. Okay, you'll see I have a stop method here. The stop method would be the same as this. You just say, as long as thread doesn't equal to no, put stop equal to true. That's how you'd have a stop button. Pause is a little bit difficult. You can't really pause a thread. If I go back to thread, they do have a suspend, but it's deprecated. Okay, it's deprecated. So the best way to pause a method at this time is to call the sleep method. But you can only call it for a certain amount of milliseconds. So it temporarily ceases the execution. Whereas pause, you could say, okay, pause and then resume. These are all deprecated. So I could do a pause method, but pause would only be done for a certain amount of time. If I go back to the slides, you'll see on the life cycle, I could call start. Now, while this thing's alive, you'll see I have 3 elements here. I have running, non-runnable, runnable, and then running again. So let's say I call the start method is running. Then I call pause or suspend or sleep. Okay, so if I call pause, it would be called suspend. This is deprecated, so I only have sleep now. Now it's non-runnable. Once sleep is done, it'll call resume, and then the Java virtual machine or the operating system will dispatch it once it has available resources. So you'll see suspend is no longer usable. It's no longer usable, it's deprecated. So the only way I have to suspend or pause a thread is with the sleep method. You'll see I have suspend, it's deprecated. You'll want to read why it's deprecated. This is a good exam question or quiz question. You'll see it's deprecated as it inherently causes deadlock issues. So it's deadlock prone. You'll want to know what deadlock is. You learn that more in operating systems, but you'll want to have a general idea. Okay, what is deadlock? Okay, if the target thread holds a lock on the monitor, protecting a critical system resource, when it's suspended, no thread can access this resource until the target thread is resumed. Okay, you don't want that to happen. Let's say I lock a file or I lock the main thread to update the UI. Now, no other thread can use the main thread, so it's just really buggy code. So they got rid of these methods because if you had access to these methods, there's a lot of potential for bugs and bad programming practices. So they got rid of them. They don't want you to use them anymore. You can use them, but you'll see I get some cross out. So you see it's crossed out saying you can use it, but don't. Or you can use it, but beware. So if I go to start thread 2, let's take a look at it. So thread 2, if I go up here, is counter thread 2. So I'll say start thread 2. I need to first instantiate it. Counter thread 2. I need 2 elements here. I need to know how long it's going to count to and where it's going to show the results, which should be a text area. So counter thread 2, let's say I count to 100 and then I display it on text area 2. Okay, I have 4 text areas. Now remember, if I start this and try to run the thread, it's not going to run, even though I instantiated it. The only way it's going to run is when I call the start method. So there's 2 important methods with threads. You have the run method and you have the start method. You're going to want to know both for the exam. The run method is where you put the code that you want to run concurrently. The start method begins execution of that thread. So if I run it by calling the start method and click start, okay, you'll see it's done. Look how fast that was. It's so quick. All you see is the last element from the for loop. We don't want that. We want the user to see all of it. So I run this and then run this. Okay, you'll see it's done. Going to 100 is really quick. It's almost instantaneous. So if you want the user to see that, you can always call the sleep. You can always pause this thread and slow it down a little bit so the user can see it. If I want to pause the thread, I can call the thread sleep method. And let's say how long do I want to sleep? Maybe 20 milliseconds. Now I can call the sleep method, but you'll see I get a warning here. Unreported exception must be caught or declared to be thrown. Remember the catch and specify requirement? So if I click this, I can surround statement with a try-catch block. I can surround the block with the try-catch block. And those are basically my 2 objects. So I'm going to click surround statement with the try-catch. What this is saying is, even though I want this thread to sleep for 20 milliseconds, there could be a chance for the operating system to interrupt this thread, which means I'm trying to sleep, maybe let's say for 20 minutes. And now the operating system says, hey, we need the CPU for another program. So it could interrupt our sleep and give those resources to another application or even to the same application. So there could be a chance for this, and then you need to handle it. Okay, you need to handle it. Normally you'd have a finally block here, and let's say I was opening a file. So I have a for loop. I'm writing into the file. I sleep a little bit, so I wait for some network connection. And let's say the operating system terminates this connection. I don't want to terminate with the file open. So I'd have a finally block and make sure I close the file before the thread finishes executing and before it's interrupted. And that's the purpose of the try catch block when the sleep method is being called. So now if I run this, I cause a little bit of pause. And this is an exam question. There's only one way to suspend a thread. Okay, the one way to suspend, probably shouldn't use that word because that's actually a method. So I actually put quotes here, suspend or pause. Okay, or pause a thread is to call the sleep method, which defines how many milliseconds to sleep. However, this is not guaranteed. Okay, this sleep method is not guaranteed. So even though you say I want it to sleep for 20 milliseconds, doesn't mean it's going to necessarily sleep for that long. So you'll see sleep causes the current executing thread to sleep temporarily, cease execution, not permanently. That's why they got rid of the suspend for the specified number of milliseconds, subject to the precision and accuracy of the system timers and schedulers. The thread does not lose ownership of any monitors. So you'll see this is more safe. Okay, it's more safe. It can't sleep forever. And it's also not guaranteed because it could be interrupted. Okay, it could be interrupted. So maybe you wanted to sleep for 20 milliseconds. The system says, hey, you can only sleep for 15. We need these resources. Now if I run this and show the system running, you can actually see it. Now it's updating the same line. Okay, I'm doing set text. So maybe what would be better is to do an append text. If I do an append text, we can see all the numbers being generated. So I can close this, run it again. And you'll see that little X that I used down here. If you have a thread that's out of control, which means you close the window and the thread is still running, you can use this little X down here to force quit the application. So I can start this one up. You'll see it's outputting to the console. If I start this one up, okay, it should also be outputting to the console, but also outputting to the UI. So they're both running simultaneously. Okay, you'll see every once in a while I have a K there. So it's a concurrent program. It's a program that's doing multiple things at the same time. Okay, if I run it again, start this up, scroll down, you'll see both of them are running. Okay, both of them are running. Now, if I remove this again, it will probably work because I only have one thread. But if you have two threads that try to update the UI at the same time, you will get a runtime error. So anytime you update the UI, it must be ran on the main thread. So if I click start here and start here, you'll see no problem. Okay, if I call it start twice, you'll see I have a problem. No pointer, no pointer. So I have some problem. If I put this back, I'm not sure if that was two threads trying to update at the same time or possibly something with the object being created, but I can try it again. So if I click start twice, you see it works. I click start twice, it works. Start 3 times, start 4 times, start 5 times. It's working. Why is it working? Because two threads are not updating the UI at the same time. So it puts it in a queue. If two threads try to update at the same time, it's in the queue. It'll update once, and it'll update the next one once it gets a chance, and therefore it prevents that runtime error, which you just saw. So we learned a lot of things here. Okay, 1, how do you create a thread? You can extend the thread superclass. 2, how do you update the UI from a thread? If you want to update the UI, it must be ran on the main thread. You'll see I said it needs to be. It must be ran on the main thread. And also, how do I suspend or pause a thread? You can call this sleep method. One thing before we close this lecture out, save this file, go over to the controller. If the user closes the window and thread 2 is still running, you want to make sure that you cease execution. So I'll say thread 2 dot stop equal to true. Then when I close the window, even though that thread is still running, it will terminate. So if I start this up, I did 3 of them, close, you'll see it closes and terminates automatically. Now let's see, one's still running here. Playground's still running. Oh, let's see, it looks like it's another application, maybe from before. Let's test that again real quick. Let's see, suspended. Let me close this out. Let me run this again. Okay, so I click, close, and it terminates. So that was a previous program running, so it works. This is good. Once you close the stage, make sure you terminate all the threads. You can't call the stop method, but you can make the run method finish executing. Now, what's the proper way to implement a thread? We've done the thread superclass on both of these examples. Let's see the textbook proper way to implement a thread. It's a little bit more difficult. It's a little bit more abstraction. It requires a little bit more of code, but it turns out to be better because I won't use my inheritance. I won't waste that inheritance, so to speak. I'm going to show you how to do that in the next video. Stick with Professor Wergeles, and we'll see you in the next video.